In the next few lessons, I'm going to be talking about general best practices. We'll essentially be going through a number of different areas, and we'll be talking about how you can structure your code so that it performs better and is a little bit more maintainable. These, of course, are just guidelines and not hard and fast rules, but they're things for you to think about when you're creating your code. So, just in general terms, you want to simplify your code. You want someone else to be able to understand your code. You, of course, don't want to support your code forever. It's nice that it would live forever, but you don't want to be stuck in support of that same code base for the rest of your life. So, you don't want that someone to come back time and time again to ask you questions about this complex spaghetti code. You want them to be able to understand it because it's readable and maintainable. And when I talk about simplifying code, simple doesn't necessarily equal fewer lines of code. You can write elegant, beautiful code that doesn't use many lines of code. However, it's very difficult for someone to understand. It may be because of the levels of extraction and complication that you've got in it, and it's beautiful code, but someone who's out of school for 2 or 3 years just won't get it. When I was interviewing people for jobs, one of the things that I used to have them do was bring in some code that they were proud of. And a guy who had a number of years of experience came in and he had some very, very sophisticated code. And we went through it and it was extremely well done. And I asked him, would someone who was 3 years out of school understand this code? And the answer was no. Well, we didn't do too well from there because the corrective action wasn't particularly good either. But that's the problem. Really beautiful, elegant code isn't necessarily maintainable by the level of people that you want to support it. So try to keep that in mind that you don't want to be the one who owns this code base for forever. You want to write it for someone else. So you want to avoid the latest tricks of the day. Methods should only do one thing. This should be somewhat obvious in object-oriented programming, or really any programming. But you don't want to have really long methods that do a whole lot of things. And we talked about a pattern that addresses that as well. You also should be consistent with your naming conventions. And we've had a lesson about naming conventions, so I won't beat that dead horse anymore. And when you're constructing your applications, think about the classes that you're going to create and the design patterns that you might be able to take advantage of. A well-constructed application will be easier to maintain. Try to use properties instead of public variables. Properties will give you access methods, the getters and the setters. And that allows you to use validation in the set method, or perhaps threading support in the get method by using locks. Now, if you just have a get and a set that doesn't do anything else, the performance is roughly the same as a public variable in .NET. It's compiled to be so. But the getters and setters allow you to expand that code if need be, so it adds some flexibility there. Also, you might prefer to use runtime constants versus compile time constants. The difference between a read-only, which would be runtime, or a const, which would be compile time. A runtime constant is more flexible. It allows complex types. Const, however, provides better performance. Because it's at compile time, it essentially takes your symbol and replaces it with whatever value you choose. So understand the difference between those two, and you might choose runtime just for that flexibility. There are a lot of best practices associated with strings. I'm just going to talk about some of the major ones. Try to use string.format or a string builder when you're creating complex strings from multiple pieces or multiple variables. String concatenation operations create another copy of the string, so it damages performance and memory. If you're just doing single concatenations, just one string added to another string, that's okay. But if you're looping and building up perhaps SQL statements that have a number of different concatenations, then you should definitely use a string builder or a format. Also use string.isNull or empty, or string.isNull or whitespace when checking to see if strings are empty. Don't write your own. This one's personally embarrassing to me because I got caught writing my own, and a junior engineer came in and said, "Why don't you just use isNull or empty?" Oh, I didn't know it was there. Sorry. Please don't make my mistake. The Microsoft website has a lot more string recommendations and a lot of details about how the comparisons are done when you're doing different kinds of string comparisons and how that affects with locales. So take a look at that. Try to use for each instead of a for loop with an integer counter. For the for each statement, the compiler will generate optimized code for the particular kind of collection being used. A for each will also allow you to be able to change the collection type later on for maintainability, rather than having to change going from a for loop to a for each if you change the collection type and having to rewrite the loop. Rewriting the loop, of course, would give you more opportunities to make mistakes. So consider using for each in your loops. Also, try to use variable initializers instead of assigning values within a constructor. So an initializer initializes a variable value when that variable is declared. So you can see we have the public class employee, and it has a private string called name, and we've initialized it to Bob. An assignment would have the constructor public employee and say name is equal to Bob, and it would be declared above this area. The reason for this, and it's not a performance issue, it's really more of a maintainability issue. If you add another constructor override, it's possible that you might forget or miss that you also have to initialize the variable name, so that you might miss that name is equal to Bob in another constructor. Whereas if you've used the initializer, that's going to apply to all constructors that you write. So you don't have to repeat that code in every single constructor override. Also brings me to the topic of constructor chaining. Again, instead of repeating code, what you would like to do if you have multiple overrides for constructors is use one constructor that actually has the code in it. So in this case, we have an override for a new customer with no parameters, and we're going to call our other constructor that has two parameters and pass in parameter values, which are going to be our initialized values. Our second constructor takes parameters for customer ID and string name, and we do whatever we need to do with those parameters in that constructor. We don't have to rewrite that code in the constructor that has no parameters if we call or chain the constructor from the no parameters to the other override that takes the two parameters. So that's a few suggestions, and we've got plenty more in upcoming lessons.